Welcome back to QHSE Talks, your ultimate health and safety knowledge hub, and your premier destination for mastering the Certified Safety Professional, CSP, examination. Today, we're diving into Chapter 39, Emergency Management and Preparedness, a chapter that aligns directly with Domain 4 of the CSP Blueprint. Because emergency management deals with the exact moment when an organization's normal operating system suddenly stops working. Think about how most organizations are structured. Everything is optimized for efficiency and stability. Production schedules assume operations will run smoothly. Supply chains assume materials will arrive on time. Managers are evaluated based on throughput, productivity, and operational performance. In short, the entire system is designed around normal conditions. But emergencies represent the opposite reality. A chemical release during routine operations, a fire spreading faster than expected, a severe weather event forcing immediate shelter or evacuation, a medical emergency or violent incident that transforms an ordinary shift into a crisis within seconds. When those moments occur, production metrics and performance targets instantly become irrelevant. The only question that matters is whether the organization is prepared to respond. That is why emergency management is not simply a checklist of procedures. It is a structured system that includes emergency action plans, evacuation strategies, medical response capability, and coordinated crisis communication. And Chapter 39 makes something very clear about who is responsible for building that system: the safety professional. According to the text, the safety professional becomes the primary resource for developing and implementing the organization's emergency preparedness plan, which means their role inside the organization is fundamentally different from most other leadership functions. Because while much of the organization is focused on maintaining smooth operations, the safety professional has to start from a very different premise. They have to assume that disruptions, crises, and emergencies are not hypothetical possibilities. They are inevitable events that the organization must be prepared to face.
And that assumption forces a massive philosophical shift within an organization.
How so?
Well, think about it. If you are a C-suite executive, your baseline assumption is growth, right? It's operational equilibrium, it's efficiency.
You want the line moving.
Exactly. You view the organization through the lens of profit and production. But the text explicitly places the burden of emergency management squarely on the shoulders of the safety professional.
It calls them the primary resource.
Yes, designating them as the primary resource for developing and implementing a comprehensive plan. And they cannot look through the lens of profit.
They have to look at the worst case scenario.
Right. They are uniquely trained to view the entire organizational apparatus exclusively through the lens of vulnerability.
I want to pause on that administrative dynamic because putting the safety professional in the center of this creates a massive friction point, doesn't it?
Oh, constant friction. Daily friction.
Because if I'm a site manager, I am judged on throughput. How many units shipped, how many patients seen, how many transactions cleared.
Right, your bonus depends on those numbers.
Exactly. And now you have a safety professional walking the floor, acting as this primary resource, and their entire job is to look at my highly efficient, profitable system and say, when this catches on fire, people are going to die because those pallets of inventory are too close to the loading dock doors.
Yeah, they are the bearer of bad news.
So how does a safety professional actually function when their core mandate is essentially at war with the operational goals of the business?
It is incredibly difficult. General management wants to maximize space, right?
Huh.
But safety wants to maximize egress.
Clear the aisles.
Exactly. Management wants to streamline the budget, but safety wants to spend capital on highly specialized redundant systems that ideally will never even be used.
Like buying an expensive insurance policy you hope to never cash in.
Right. The reason Yates's text demands the safety professional be the primary resource is precisely because they are insulated from the seduction of operational optimism.
Operational optimism. I love that phrase.
They have to be the designated pessimists. When everyone else is looking at the spreadsheet, the safety professional is looking at the proximity of the chemical storage tanks to the local floodplain.
Or calculating, like, the thermal load of the server farm.
Precisely. They're the only personnel equipped to translate a theoretical disaster into an actionable administrative protocol.
But practically speaking, and this is something I really want to push back on a bit, if the text is right and an emergency can happen at any place in time, how does that not induce just total operational paralysis?
It can, if you approach it wrong.
Because if I am that safety professional and the threat matrix includes a localized tornado, an active shooter, a massive power grid failure, an undetected ammonia leak, and, I don't know, a cyber attack that locks the physical security gates.
It's overwhelming.
It's completely overwhelming. How do I avoid just throwing my hands up? You can't write a 5,000-page manual covering every conceivable permutation of disaster.
No one would read it.
Exactly. And certainly no one is going to, like, consult the index while the building is actively filling with smoke.
You're absolutely right. And the answer is, you don't write the 5,000-page manual. This is where your skyscraper analogy from earlier perfectly illustrates the methodology.
The shock absorbers.
Exactly. The architect doesn't try to predict the specific waveform of the earthquake. They build the shock absorbers.
Right.
The safety professional doesn't try to write a script for every hyper-specific disaster. Instead, they build resilient administrative and physical systems.
So it's more about the foundation than the specific event.
Precisely. They establish universal chains of command, redundant communication trees, and decentralized medical response capabilities. They engineer a state of baseline readiness that can absorb the kinetic shock of any unpredictable event.
Okay, that makes sense.
If you build a robust, universally understood evacuation protocol, it honestly doesn't matter if the evacuation is triggered by a grease fire in the cafeteria or a bomb threat.
The mechanism of getting humans out of the structure remains resilient either way.
Exactly. The human behavior is what you're training, not the response to the specific trigger.
So the goal isn't a library of specific scripts. It's a flexible, universally applicable engine of response. And that transitions us directly into the architectural framework that Chapter 39 identifies as the core of all emergency planning.
Yes, the heavy lifter of the chapter.
The text explicitly anchors emergency management programs to Edward Deming's PDCA model. That's plan, do, check, act.
Deming's cycle is the engine of continuous administrative improvement. And it's vital we dissect this, because the popular corporate understanding of an emergency plan is deeply, deeply flawed.
How so? Like, what are people getting wrong?
Most organizations treat the emergency plan as a static artifact. It's a beautifully formatted 3-ring binder sitting on the safety director's shelf.
Oh, I've seen those binders, usually covered in dust.
Exactly. It gets drafted to satisfy an insurance auditor, printed out, placed on the shelf, and then completely ignored as the facility around it evolves.
Right.
The source text is fiercely arguing against that static artifact.
Because a static plan in a dynamic environment becomes obsolete the absolute second you hire a new employee or, like, move a piece of heavy machinery.
It's out of date instantly.
So let's walk the listener through the mechanics of Deming's cycle in the context of high-stakes emergency management. Let's start with plan. This isn't just, drawing arrows on a floor map, is it?
Far from it. The plan phase is rigorous hazard identification and risk assessment.
What does that look like in practice?
This is where the safety professional cross-references facility blueprints with local topographical data. They analyze historical incident reports, and they model worst-case scenarios.
So it's a lot of data analysis up front.
Heavy data analysis. If you are operating a massive cold storage logistics hub, your plan phase involves calculating the dispersion rate of an anhydrous ammonia leak based on the cubic footage of the facility and the capacity of the HVAC system.
Wow, so you're actually doing the math on how fast the gas spreads.
Exactly. You are designing the initial shock absorbers on paper.
Okay, so that's the plan. Then we move to do implementation. You have the blueprint. Now you have to actually build the physical and administrative infrastructure.
Correct. The do phase requires massive capital and logistical execution.
Spending the money.
Spending the money and the time. You are purchasing the specialized, self-contained breathing apparatuses. You are installing the audible and visual strobe alarms for high-noise environments.
Because if it's too loud in the factory, they won't hear a standard bell.
Right. You need the strobes. You are conducting the initial exhaustive training sessions with the floor supervisors. You are putting the theoretical blueprint into physical motion on the operational floor.
And honestly, this is where the static binder approach usually stops, right? They planned it, they bought the gear, they did a mandatory PowerPoint presentation, so they just assume they're safe.
Check the box and move on.
But Deming's cycle introduces the crucial third phase, which is check.
And the check phase is the deliberate, controlled stress testing of your shock absorbers. You do not wait for a catastrophic ammonia leak to find out if your evacuation routes are viable.
Because if you wait for the real thing, it's too late.
Exactly. You simulate the disaster, you run full-scale drills, but more importantly, you measure the performance of that drill with clinical precision.
Okay, let's run a hypothetical here to really see the friction of this cycle. Let's say a manufacturing facility runs an unannounced fire drill. The alarms trigger. The safety engineers are stationed at the rally points outside with stopwatches.
A classic check scenario.
Right. And let's say the plan stated that based on the occupant load and the egress geometry, the entire building must be cleared and accounted for in 3 minutes. But the stopwatches at the rally point show it actually took 7 minutes and 45 seconds.
Well, in the context of a rapidly propagating industrial fire, a nearly 5-minute delay is a catastrophic, fatal failure of the system.
Exactly. People would not survive that. So the check phase just proved that the shock absorbers are broken. Now, if the organization isn't committed to the whole PDCA cycle, the site manager might just shrug, log the drill to satisfy the local fire marshal, and tell everyone to, I don't know, walk faster next year.
Which solves absolutely nothing.
Right. But Deming's final phase, ACT, forces a completely different administrative response.
The ACT phase is where the uncomfortable, expensive work happens. You cannot simply repeat a flawed drill. You must perform a root cause analysis on the failure.
You have to figure out the why.
Why did it take 7 minutes? Did the workers on the mezzanine level fail to hear the alarm over the sound of the stamping presses?
Oh, because the strobes weren't placed right.
Exactly. Or did a newly installed conveyor belt block a primary exit aisle? Did supervisors waste precious time attempting to shut down non-critical machinery before evacuating?
You investigate all those friction points, and once you isolate them, the ACT phase demands that you change the physical environment or the policy to illuminate those points.
You have to fix it.
You install louder, low-frequency sounders on the mezzanine. You physically reroute that new conveyor belt. You rewrite the shutdown protocol to mandate immediate abandonment of the line.
And crucially, once you implement those changes, the cycle violently snaps right back to the beginning.
It starts over.
It starts over. You plan the newly revised routes. You do the new training on the revised shutdown protocols. You check the system with another drill to verify the changes actually worked. And you act on whatever new minor friction points that second drill reveals.
It never ends.
Never. If we connect this to the bigger picture, Deming's model isn't just for manufacturing quality. It's a universal law of organizational survival. A facility is an organic, shifting entity.
People quit, new machines come in, layouts change.
Exactly. And if the emergency framework isn't constantly adapting to the subtle daily changes in personnel, equipment, and architecture, the safety margin is actively decaying.
So Deming provides the philosophical engine. It gives us the perpetual motion machine of continuous improvement. But, an engine needs parameters. It needs to know what specific metrics it's trying to achieve.
It needs a map.
Right. And that shifts our focus to the global benchmarks detailed in Chapter 39. Because the safety professional doesn't have to invent the standards of preparedness out of thin air. They rely on established frameworks. Specifically, the text mentions ISO 4501 and CSP Z10.
These are the heavyweights of occupational health and safety management systems.
Let's start with ISO 4501. What is that exactly?
It's an international standard recognized globally. It provides a highly structured framework for an organization to manage risks and improve their occupational health and safety performance.
It's not a law, right?
No, it is a voluntary consensus standard, meaning a company chooses to pursue certification to prove to clients, regulators, and employees that they operate at the highest level of safety management.
Okay, so the source text zeroes in on a few very specific mandates within ISO 4501 regarding emergency preparation.
What does it highlight?
It requires certified organizations to establish provisions for first aid, highly specific training regimens, periodic testing, which, by the way, perfectly aligns with Deming's check phase.
Yes, the testing is non-negotiable.
But there's a really critical point regarding communication. ISO 45001 specifically mandates that the emergency plan must be communicated not just to employees, but to visitors and contractors.
Ah, yes. That inclusion of transient populations, the visitors and contractors, is where the theoretical elegance of ISO 4501 meets the brutal, chaotic reality of a working facility.
Because they don't work there.
Right. It addresses a massive, historically fatal blind spot in emergency planning.
Walk me through the mechanics of that blind spot. Why is this such a heavy lift for a safety manager?
Well, consider the administrative control you have over a full-time employee. You control their onboarding. You can mandate they sit in a conference room for 4 hours on their first day and memorize the evacuation routes, right?
Yeah, you pay them to learn the rules.
You teach them the specific tones of the different emergency alarms, the locations of the eye wash stations. They possess institutional knowledge of the physical space.
Okay, so they know the drill.
Now consider a massive petrochemical plant undergoing a routine maintenance turnaround. On a Tuesday morning, 2,000 external contractors arrive on site.
2,000.
Easily. Welders, pipe fitters, crane operators. They do not work for the plant. They do not know the layout. They do not know that a 3-second undulating siren means a toxic gas release, while a continuous blast means a fire.
That is terrifying. And beyond heavy contractors, you have the daily influx of temporary visitors, too.
Oh, constantly.
The vendor dropping off office supplies, the corporate auditor visiting from out of state, the HVAC repair technician working completely alone on the roof.
Precisely. And if a catastrophic event occurs, the hazardous chemical or the structural fire does not differentiate between a 10-year veteran employee and a delivery driver who just walked through the front door 3 minutes ago.
Fire doesn't check ID badges.
Exactly. The ISO 45001 standard dictates that your emergency system must account for the survival of the person who possesses zero institutional knowledge of your facility.
But how does a safety professional practically execute that? I mean, you cannot mandate a 4-hour safety orientation for a vendor who is only going to be in the building for a 20-minute meeting.
The operational friction would be absurd. You'd never get anything done.
Right. How do you satisfy the rigorous communication demands of ISO 45001 in, 10 seconds?
You have to engineer the communication into the environment itself and into the basic administrative protocols of entry. You use psychological engineering to make complex life safety information instantly digestible.
I actually saw a brilliant execution of this recently. I was consulting at a large-scale manufacturing plant. I went through the standard security gate, handed over my ID, and they printed a visitor badge.
Pretty standard so far.
But the badge wasn't just a piece of paper and a plastic sleeve. It was a heavy, brightly colored card. The front had my name, but the entire back was a highly engineered, simplified schematic.
Oh, a map on the badge.
Yeah, and it had a massive "You Are Here" star. It had thick, unmistakable red arrows charting the most direct path to the nearest exterior assembly area. And below the map, there were 3 bullet points with universally recognizable icons.
What kind of icons?
Like a flame icon next to continuous alarm equals evacuate. A tornado icon next to pulsing alarm equals shelter in interior hallway, and a medical cross with an internal emergency phone number.
See, that is the physical manifestation of the ISO 45001 communication mandate.
It was so simple but so effective.
Because the safety professional at that facility recognized that they only had the 5 seconds. It takes a security guard to hand over a lanyard to establish an emergency baseline.
They didn't rely on me reading a manual.
No, they put the shock absorbers quite literally around the visitor's neck.
That's a great way to put it.
Yep.
And the text notes that ANSI CSP Z10, which is the American National Standard for Occupational Health and Safety Management Systems, it echoes these exact same requirements.
They align very closely.
These standards demand a holistic view of the physical space and every single human body occupying it, regardless of their payroll status.
But we must draw a sharp distinction here, because ISO and ANSI are voluntary consensus standards.
Right, nobody goes to jail for failing an ISO audit.
Exactly. They are the professional benchmarks of excellence. If an organization achieves them, it indicates a highly mature safety culture. However, a site manager can choose to ignore ISO 45001 and simply not pursue certification.
They can just opt out.
They can. The government, on the other hand, does not deal in voluntary excellence. They deal in mandatory compliance.
And that brings us to the absolute law of the land. Chapter 39 transitions from the aspirational frameworks of ISO to the rigid, punitive, and highly detailed directives of OSHA.
The Occupational Safety and Health Administration.
Yes. Under Title 29 of the Code of Federal Regulations, OSHA isn't suggesting best practices. They're issuing federal law. And the text highlights several specific regulatory arenas, starting with the concept of means of egress.
Egress.
This is under 29 CFR 1910.35 through 37 and 1926.34.
Egress is perhaps the most critical, heavily litigated, and universally applicable concept in all of safety engineering.
Really, just getting out of the building.
Oh, absolutely.
Yeah.
To the layperson, egress just means the exit door. But OSHA defines means of egress as a continuous and unobstructed way of exit travel from any point in a building or structure to a public way.
Any point.
Any point. It is a strictly defined three-part journey.
Break down that three-part journey for us, because the nuance here is where organizations end up facing massive federal fines or, worse, fatalities.
Right. So OSHA legally segments egress into the exit access, the exit, and the exit discharge.
Okay, let's take those one by one. Exit access.
The exit access is that portion of the route that leads to an exit. Think of the aisles between cubicles in an office or the main corridors on a factory floor.
Basically the path you take to get to the door.
Yes. Then you have the exit. This is that portion of the route that is generally separated from other areas to provide a protected way of travel.
So this isn't just a door to another hallway.
No, this is typically the fire-rated stairwell or the actual fire door itself that leads out.
Okay, and the third part?
Finally, the exit discharge. This is the part of the route that leads directly outside or to a street, walkway, or public way.
So if I have a perfectly compliant, heavy-duty, fire-rated exit door, which satisfies the exit part of the equation, but the hallway leading up to it is currently being used to temporarily store, a dozen pallets of printer paper.
Which happens all the time.
Right. I haven't just created a nuisance, I have fundamentally violated federal law regarding the exit access.
Exactly. OSHA demands that the entire journey, from the worker-specific station all the way to the public street, is mathematically sufficient to handle the occupant load and completely devoid of obstruction.
Mathematically sufficient, like they measure the hallways.
Down to the inch. And the historical context for this rigidity is literally written in blood.
It always is with safety regulations.
It is. The extreme granularity of OSHA's egress standards is a direct legislative response to historical atrocities, like the Triangle Shirtwaist factory fire.
Right, where the doors were locked.
Yes. Exit doors were locked to prevent unauthorized breaks, and exit accesses were blocked by scrap fabric and narrow aisles, leading to mass fatalities.
People couldn't get out.
OSHA's mathematical rules for the width of a hallway or the swing direction of a door. They are engineered to prevent the physics of crowd crush and the psychology of panic from overriding the physical architecture.
The administrative friction of maintaining that perfect egress in a dynamic environment, though, it's staggering.
It's a full-time job.
Imagine a busy retail stockroom during the holiday season. The inventory is flowing in constantly. The pressure from management is to get the product off the trucks and into the building.
Time is money.
Right. And the easiest place to drop a pallet of excess inventory is right in front of that emergency fire door. Just for an hour, just until the floor clears up.
A little bit later.
Exactly. But the safety professional has to walk in and demand that production stop until that path is cleared, because an emergency doesn't care that it's the busy season.
That is the daily battle. And the text further contrasts how OSHA handles different industrial environments, specifically noting fire prevention plans in the construction industry versus process safety management in general industry.
Okay, let's explore that contrast. Why does a construction site need a fundamentally different regulatory approach than a general manufacturing facility?
Because a construction site is an inherently fluid, temporary, and rapidly evolving environment.
It changes every day.
Literally. Under 29 CFR 1926, the fire prevention protocols must account for an architecture that literally changes shape from Tuesday to Thursday.
Right. Walls go up, floors get poured.
The hazards are highly variable. You have temporary electrical runs, active hot work like welding, the introduction of massive quantities of combustible materials before the fire suppression systems are even installed.
Because the sprinklers aren't even working yet.
Right. An egress route on a construction site might be a concrete stairwell one week and a temporary wooden scaffold the next. The emergency plan must be incredibly agile just to track the hazard.
Now pivot that to process safety management, or PSM, in general industry. This is a completely different beast, according to the text.
PSM is OSHA's highly complex standard for managing the integrity of operating systems that handle highly hazardous chemicals.
So we are not talking about a pile of lumber catching fire here.
No, We are talking about the catastrophic release of toxic, reactive, or highly explosive gases and liquids. If you run a refinery or a chemical plant utilizing massive quantities of chlorine, the emergency plan is not simply run to the exit.
Right, because if a high-pressure catalytic cracker begins to fail or a cooling system on an exothermic reactor goes down, running away immediately might guarantee a catastrophic explosion that levels a city block.
Exactly. You can't just leave it. PSM mandates deeply technical emergency shutdown procedures. The plan must designate specific employees who do not immediately evacuate.
They have to stay behind.
They are tasked with remaining in the hazard zone to execute sequential valve closures, isolate chemical lines, and depressurize systems before they can safely retreat.
That is a massive responsibility.
It is. The regulatory burden on training, mechanical integrity, and emergency pre-planning under PSM is astronomical compared to a standard commercial space.
Which brings up a really vital synthesis of everything we've covered so far. This raises an important question, right? You have the Deming PDCA cycle plan, do, check, act, which is a flexible, continuous, holistic philosophy of improvement.
Right.
And then you have OSHA, which is this massive, unforgiving volume of highly specific legal checklists and mathematical requirements. How does a safety professional reconcile the philosophical flexibility of Deming with the rigid legalism of OSHA?
It is the delicate tightrope of the profession. Think of OSHA as the skeletal structure and the PDCA cycle as the muscular system.
Okay, I like that analogy.
OSHA dictates the mandatory geometry.
Okay.
You must have an egress route of this exact width, and you must have a PSM shutdown sequence documented. That is non-negotiable.
The skeleton doesn't bend.
Right. But Deming's PDCA cycle is how the organization ensures that skeletal structure actually functions under stress.
So OSHA says, build a door this wide. Deming says, run a drill, figure out that everyone panics and bottlenecks at the door anyway, and act to train them on orderly phased evacuation.
Precisely. OSHA is the baseline of legal compliance. PDCA is the engine of functional survival. You use the continuous improvement cycle to perpetually audit and refine your compliance with the rigid law.
Okay, up until this point in our deep dive, the hazards we've discussed have been fundamentally structural or chemical. An earthquake, an ammonia leak, a blocked egress route, a fire.
Physical threats.
Right. These are emergencies governed by the laws of physics, thermodynamics, and fluid dynamics. They are mindless forces.
They don't have intent.
But Chapter 39 takes a profound and necessary pivot here. It expands the definition of emergency to encompass a threat that possesses a human brain, intent, and the ability to adapt to your security measures. We are moving into the terrifying realm of workplace violence.
This is a critical paradigm shift in safety engineering.
Why is it such a big shift?
For decades, the safety profession focused almost exclusively on the machine injuring the worker or the building failing the worker.
The gears catching a sleeve or the roof collapsing.
Exactly. The inclusion of workplace violence in an emergency management text acknowledges that the human element is often the most volatile and lethal hazard in the operational environment.
The source text outlines a specific list of risk factors for workplace violence, and I want to read this list carefully because the implications are massive.
Go ahead.
Chapter 39 states that high-risk scenarios include working in care, social work, or the justice system, working alone or in small numbers, working late at night, working in high-crime areas, guarding valuable property or possessions, and working in community-based settings.
It covers a lot of ground.
It does. When you look at that list as an expert, what is the underlying administrative and psychological pattern?
The pattern is a grim equation. Vulnerability equals isolation multiplied by high-stakes environments or vulnerable populations.
Let's break down the variables in that equation. Let's look at high-stakes environments first.
Okay, consider the justice system or guarding valuable property like an armored car courier or a late-night retail manager handling cash drops.
High-value targets.
The stakes are primal. Massive amounts of money, narcotics, or physical freedom. The incentive for an external threat to employ violence is incredibly high.
Right.
Now, multiply that high incentive by the variable of isolation working late at night or working alone in a small number. The isolation removes the strongest natural deterrents to human violence.
Which are what?
The presence of witnesses, the immediate availability of backup, and the psychological barrier of a crowd.
Now let's swap the high-stakes variable for vulnerable populations, like the text mentions, with care, social work, and community settings.
In a clinical or social work setting, the stakes aren't necessarily cash. The stakes are deeply personal and emotional.
It's someone's life or their family.
Exactly. You are dealing with individuals who may be experiencing acute mental health crises, devastating medical diagnoses, extreme systemic desperation, or the removal of child custody.
Highly charged situations.
The environment is highly emotionally charged. When you place a lone healthcare worker or social worker into that community setting, isolated from immediate institutional security, the risk matrix spikes exponentially.
But I have to challenge the scope of this. When I look at those risk factors, working late at night, working in small numbers, working in community settings, that doesn't just describe a prison guard or a specialized psychiatric nurse.
No, it doesn't.
That describes a staggering percentage of the modern service economy. Every late-night convenience store clerk, every fast food worker closing the drive-thru at 2 a.m., every delivery driver navigating a high-crime neighborhood. Are you saying the text implies all of these roles are operating in a state of high-risk emergency vulnerability?
Yes, absolutely. And that is the sobering reality that the modern safety profession is currently wrestling with. We have to fundamentally broaden our definition of what constitutes an emergency. Historically, a safety manager at a corporate retail chain might only focus their PDCA cycle on mitigating slip and fall hazards, ensuring the fire extinguishers are inspected, and keeping boxes out of the aisles.
The traditional physics-based hazards we talked about.
Right. But this text forces the realization that if you schedule a lone 19-year-old worker to close a retail store at midnight, the possibility of an armed robbery or a violent customer assault is just as statistically foreseeable, if not more so, than a structural fire.
Wow.
Therefore, evaluating the psychological and physical security of that lone worker cannot be relegated to an afterthought. It must be subjected to the exact same rigorous Deming cycle as the chemical storage tanks.
So you run PDCA on the night shift scheduling?
Exactly. How do you plan the architecture of the store to maximize visibility? How do you do training on compliance and de-escalation? How do you check the response times of panic buttons?
That is a massive operational shift. It moves the safety professional from just engineering the physical space to analyzing the psychological threat profile.
It changes the whole job.
And to effectively build shock absorbers against human violence, you have to understand the specific nature of the threat. It's not a monolith. And this leads to the final, incredibly nuanced concept in Chapter 39, the typology of workplace violence.
Categorizing the threat is the bedrock of targeted emergency planning. If you misdiagnose the type of violence your facility is facing, your administrative controls and physical engineering will completely fail when the crisis occurs.
The source text identifies specific typologies, and we need to contrast the two primary ones. Type 1 is defined as criminal intent.
Right.
These are violent acts committed by individuals who have no legitimate relationship to the business or its employees. They enter the workplace specifically to commit a crime, like robbery or terrorism.
The outsider threat.
And then type 2 is defined as worker versus customer. This involves violence directed at employees by customers, clients, patients, students, or inmates, individuals who have a legitimate, established reason to be interacting with the organization.
The distinction between type 1 and type 2 violence dictates entirely different methodologies for emergency preparation. You cannot use a type 1 response plan for a type 2 emergency.
Walk the listener through the structural difference. Let's start with type 1, criminal intent. The threat is a stranger violently breaching the perimeter to steal resources. How does a safety professional use the PDCA cycle to prepare for that?
Preparing for type 1 violence relies heavily on physical security, environmental design, and target hardening.
Target hardening?
Making the building physically harder to attack. Because the threat is an external unknown whose primary goal is the extraction of resources, your plan phase is focused on deterrence and delay.
How do you do that?
You employ CPTID crime prevention through environmental design. You install high-lumen exterior lighting to eliminate shadows. You engineer the landscaping to prevent hiding spots.
Cutting down the bushes near the entrance?
Exactly. You install bullet-resistant enclosures, time delay safes, and biometric access controls.
It's almost entirely structural. You are building physical barriers to keep the bad element out or to severely limit their operational timeline if they do force their way in.
Exactly. The do phase training for employees in a type 1 scenario is usually focused on strict compliance.
Like, don't be a hero.
Exactly. If an armed individual breaches the perimeter for cash, the protocol is not to negotiate or de-escalate their emotional state. The protocol is to hand over the cash, avoid sudden movements, utilize silent duress alarms if it's safe to do so, and preserve human life at the cost of the physical asset.
Let them take the money.
Yes. But the moment we pivot to type 2, worker versus customer, the entire geometry of the emergency violently shifts.
It shifts because the core assumption of type 1 keeping the threat outside the perimeter is irrelevant.
Yeah.
In a type 2 scenario, the individual who becomes violent was legally and organizationally invited into the space.
Exactly. You can't put a bulletproof glass partition between a physical therapist and their patient.
No.
You can't put a time delay lock on the social worker conducting a home visit. The worker is required, by the very nature of their job, to be in intimate, unprotected proximity to the potential threat.
So the heavy physical fortifications of type 1 are largely useless here.
Pretty much.
Therefore, preparing for type 2 violence requires a profound shift towards psychological engineering, advanced administrative controls, and highly nuanced spatial awareness.
The shock absorbers are behavioral, not physical.
Let's paint a comparative picture to make this administrative friction perfectly clear. Think about a commercial bank teller dealing with an armed takeover robbery.
Classic type 1.
Right, classic type 1 criminal intent. The emergency plan dictates the teller complies, gives up the die-packed cash, and lets the highly engineered physical security systems, the high-definition cameras, the reinforced vault doors, the silent alarms, do the heavy lifting. The bank robber wants the asset and wants to leave.
Right. Now, contrast that with a caseworker in a county social services office. They're sitting in a small enclosed interview room. Across from them is an individual who just received paperwork stating their vital housing or medical benefits have been permanently terminated.
Oh, wow.
The client experiences a catastrophic acute stress reaction and becomes violently enraged. That is type 2 worker versus customer violence.
The agitated client isn't trying to rob the office. They're having a localized interpersonal crisis directly targeted at the worker who represents the bureaucratic system that just ruined their life.
Yes.
If that social worker tries to use the bank teller's emergency plan, just sit still and hope they leave, they're going to get severely injured.
Exactly. They won't just leave. If the safety professional for that social services agency properly utilized the Deming cycle, they would have identified this specific type 2 vulnerability during the plan phase.
Their preparations would look entirely different from the bank's.
Completely different. The do phase would focus on rigorous scenario-based de-escalation training. It would teach the worker how to recognize the physiological precursors to violence.
What does that look like?
The clenching of hands, the change in vocal cadence, the shifting of body weight, the sudden silence.
And it changes the physical design of the room, too, right?
Completely. The plan dictates spatial engineering. In that small interview room, the social worker's chair must always be positioned closer to the exit door than the client's chair.
Ensuring a clear, unobstructed path of retreat.
Always. The room must be stripped of potential improvised weapons. No heavy glass paperweights, no loose scissors on the desk.
Everything bolted down or removed.
And the administrative controls would include a system of coded, innocuous phrases.
Like a safe word.
Basically, the worker could pick up the phone, call the supervisor, and ask to verify file 99, which secretly alerts the entire floor that immediate security intervention is required, all without further escalating the client's anger.
Because if you say, I'm calling security, they might attack immediately.
Exactly. Both the bank robbery and the clinic assault are terrifying, life-threatening emergencies. But the engineering of the preparedness, the fundamental architecture of the response, is night and day.
And if an organization fails to recognize which typology they are exposed to, their emergency plan is fundamentally useless.
It really brings the immense burden of the safety professional into sharp focus. They have to evaluate the sprawling bank, they have to evaluate the intimate social work clinic, and they have to evaluate the noisy, chaotic manufacturing floor.
And for each vastly different environment, they must power up Deming's continuous cycle.
They have to ensure absolute compliance with OSHA's mathematical egress standards.
They have to integrate ISO 4501's communication protocols for transient visitors.
And they have to meticulously tailor all of it to the specific typology of human or environmental hazard that facility is mathematically destined to face.
It is an almost incomprehensibly complex, multidimensional administrative puzzle. And the stakes for solving it incorrectly are literally human lives.
No pressure, right?
Right. I want to pause here as we wrap up this extraction and speak directly to you, the listener. We've covered a massive amount of technical and psychological ground today. Think about your own operational environment.
Think about the physical building you enter every morning, the site you manage, or the team you lead.
Evaluate those vulnerabilities.
Exactly. Are you facing the mindless kinetic energy of a chemical process, the external threat of criminal intent, or the internal friction of customer conflict? And more importantly, does the administrative architecture of your organization actually address that specific reality? Or are you simply relying on a static, dusty binder on a shelf and a map with red arrows pointing to a locked door?
That is the uncomfortable audit that Chapter 39 demands of its readers.
Yeah.
Because a meticulously formatted plan that only accounts for a fire in a facility where the statistical danger is interpersonal violence is not an emergency plan.
It's just a binder.
It is a dangerous delusion of safety.
We started this deep dive with the harsh baseline certainty that the ground will eventually shift. Emergencies will happen. We explored the philosophical engine of Deming's plan, do, check, act cycle, proving that resilience requires continuous administrative motion.
You can't just plan once.
Right. We navigated the massive friction of implementing voluntary benchmarks like ISO 4501 and the rigid, non-negotiable legal directives of OSHA's egress and process safety standards. And finally, we translated all of that structural engineering into the complex, volatile realm of the human element, dissecting the critical differences and typologies of violence.
It is a vast, heavy landscape of responsibility. But I want to leave you with one final provocative thought to mull over as you walk through your own facilities, building on the text's opening assertion that disasters are an absolute inevitability.
What's that thought?
If an organization's emergency plan only prepares them for the specific disasters they can easily imagine, or the ones that have already happened, is it truly an emergency plan? Or is it just a scheduled routine for a slightly worse than average day? True preparedness, true safety engineering requires building a system that is resilient enough and flexible enough to survive the unimaginable.
Because at the end of the day, when the structural fault line finally snaps, or the chemical pressure breaches the valve, or the unpredictable human element walks violently through the front doors, you don't want to rely on the hope that the ground will stay still.
Hope is not a strategy.
It's really not. You want the absolute certainty that the administrative shock absorbers you built into the foundation are going to hold the weight of the chaos. Thank you for joining us on this deep dive into the source material today. Keep interrogating your systems, keep searching for the friction points, and stay safe out there.